Hello everyone. Today I will discuss past paper probability and statistic 2, May June 2020. This is question number 3. In a data entry department of a certain firm, it is known that 0.12% of the data items are entered incorrectly, and that these errors occurs randomly and independently. Question A. A random sample of 3600 data items is chosen. The number of these data items that are incorrectly entered is denoted by X. I. State the distribution of X, including the value of any parameters. Now, since in this question we know the number of trials that take place, that is 3600, and then fixed probability of 0.12%, this is the binomial distribution with parameter n, the number of trials take place, that is 3600, and the probability, fixed probability, that is 0.12% or 0.0012. Thus answer for I is that is binomially distribution with parameter n 3600 and p 0.0012. II state an approximating distribution for X, including the values of any parameters. Justify your choice and approximating distribution. No, the original distribution, that is binomial, parameter n 3600 and p 0.0012, and since n 3600 more than 50, and n times p, that is 3600 times 0.0012 equals 4.32 less than 5, X can be approximated by the Poisson distribution with parameter, that is the mean, n times p 4.32. Thus X can be approximated by Poisson distribution with mean 4.32. III, use your approximating distribution to find the probability of X more than 2. No, the approximating distribution, that is a Poisson. This is the formula for Poisson distribution. Probability of X equals E power minus lambda times lambda power X per X factorial. Thus lambda is the mean, and already calculated, that is 4.32. Thus probability of X more than 2, that is equals 1 minus probability of X equals 0 plus probability of X equals 1 plus probability of X equals 2. No. Thus when X 0, probability of X 0 means E power minus 4.32 times 4.32 power 0 divided by 0 factorial, that is, thus this is 1, thus left over E power minus 4.32, that is why here this is for probability of X equals 0, that is E power minus 4.32. For probability of X equals 1, that is E power minus 4.32 times lambda, yeah. And then for probability of X equals 2, that is E power minus 4.32 times lambda squared, 4.32 squared divided by 2 factorial, thus that is 2. And enter it in your calculator. We obtained that probability of X more than 2, that is 0.805, correct to 3 significant figures. This is the answer for triple I. B. Another large random sample of n data items is chosen. The probability that the sample contains no data items that are entered incorrectly is more than 0.1. Use an approximating distribution to find the largest possible value of n. No, those here actually probability of x equals 0 more than 0.1. Those entered in the Poisson distribution formula. Those e power minus lambda times lambda power 0 divided by 0 factorial more than 0.1. Lambda power 0 is 1, 0 factorial is 1, thus this left over e power minus lambda more than 0.1, and take logarithmic both side, that is take a natural logarithm for both side, thus ln e power minus lambda, that is minus lambda, more than ln 0.1. 0.1 we can write it 10 point minus 1, and by using of laws of logarithm, minus 1 move front, thus minus ln 10. Divide minus 1 for both side, thus minus lambda divided by minus 1, that is lambda, and reverse the direction of the inequality sign, since divided by negative, thus less than minus ln 10 divided by minus 1, that is ln 10. Now lambda is, that is n times p, and p is 0.0012 and n is unknown, thus replace lambda by n times p, that is 0.0012 n less than ln 10, n less than ln 10 divided by 0.0012, that is use your calculator, n less than 1918.82, etc. Thus the largest value of n is 1918. Thus this is the answer for B, that is 1918. Now that is all for today. See you in the next video. Thank you.